Hi and welcome to yet another video on my channel named The Rise of Quantum Computing. Now you might think what theme of the channel is really. I mean the videos that I put on my channel have a very vast wide range. But the fact is I'm a really curious person and I like to read about a couple of different things, and therefore that reflects on this channel because I make videos on a wide range of topics. So let's get started um, with the video that is titled The Rise of Quantum Computing. So, alright, let's start with the basics. We all know about our regular computers, right? Of course, we all know that. These regular computers where we use them to check our emails and watch videos, and of course watch awesome videos like this. uh, of course, phone, computer, anything, any electronic device. So well, these computers run on something called as bits. These are really tiny switches that can either be on or off, represented by 1 or 0. Like on represents 1 and off represents 0. This is what we called binary, and this is the foundation of our digital technology. Whether you are sending a text message or streaming any video or movie, it's all powered by bits. Now here's where things get interesting. Quantum computers doesn't use your regular bits. They use something called as quantum bits or qubits. So what makes qubits so special? Well, unlike regular bits that can be on or off, that can be 1 or 0, qubits can be both 1 and 0 at the same time. How crazy is that? And this phenomenon is called superposition. Okay, so imagine you flip a coin, and it should ideally be heads or tails. But instead of landing on a heads or a tails, it's somehow both heads and tails at the same time. Sounds wild, right? But that is the power of quantum mechanics, and this blows my mind every single time I think about it. So I remember the first time when I heard about about superposition, when I was sitting in my when I was in my 12th grade and I was sitting in my physics class, and the professor was explaining how a quantum computer could solve multiple problems simultaneously because of superposition. I was sitting there and I was trying to picture this. How can a coin be both heads and tails? And that just blew my mind at that point of time. And it blows my mind at this point of time also. And it's one of these concepts which makes you literally rethink everything you know about how the world works. And it's completely amazing. But there's more. Uh, quantum computers uh, also use something called as entanglement, and this is even more mysterious. When two qubits become entangled, the state of one qubit instantaneously affects the state of the other, no matter how far they are. It's like having two magic dice, the one which we roll when we play ludo or snake and ladder, so that dice. So if you roll one dice and it lands on a 6, and the other one, even if it's in the other side of the world, it will also land on a 6 at the same moment. This is so strange that even Einstein, Albert Einstein, one of the greatest mind in the history, he called this a spooky effect at a distance. I don't understand what this spooky effect on a distance mean, but then that's what he framed it as. But then this is so fascinating and mind blowing that even Einstein thought it's a spooky action. So, okay, that all is fine, but why does all this matter? Well, because of superposition and entanglement, quantum computers can process huge amounts of information all at once. So, this means like solving a certain problem much faster than classical computers. We are talking about problems that can take a regular computer, say, thousands or even millions of years to solve a particular problem. Imagine trying to solve a super complex puzzle which a classical computer would go piece by piece. A quantum computer can look at all the pieces at once and see the solution almost instantly. Now you might be wondering, if quantum computers are so powerful, why aren't we using them already and everywhere to do all of our things? But the catch here is quantum computing is still in its infancy. Building a quantum computer is incredibly difficult. These machines are super sensitive to their environment and need to be kept at extremely low temperature, which is colder than the outside space. The slightest vibration or heat can cause the qubits to lose their quantum state, and this is what is called decoherence. I remember reading about uh, this lab, which is where a special suits and where the people working in the lab are required to wear special suits and work in total near silence to avoid disturbing the qubits. It's like trying to perform a very delicate surgery, but then you are hanging on a tightrope. So this is such a difficult and the task requires so much precision. So it is so difficult to perform operations on qubits. But despite all these challenges, we are making massive progress. Uh, Companies, FANG companies, big tech companies like Google and IBM and Microsoft are investing heavily in quantum computers. You might have heard about Google's milestone in quantum supremacy, right? It means that they are able to perform calculations where their quantum computer that would have taken, so the quantum computer is able to solve the problems which take a classical computer thousands of years to solve. And this is a huge moment in the tech world, and it's like, let's say, Wright brothers taking their first flight. Okay, a bit exaggerating, but then this is actually really huge thing. Working, making quantum computers a reality. Um, but now let's break it down a bit further. Classical computers solve problems step by step, following a specific path to get to a solution. While quantum computers, on the other hand, can explore many paths all at once thanks to superposition. It's like having a team of explorers who can take different routes simultaneously to find the best way of the treasure. This ability makes quantum computers incredibly powerful for certain tasks like factoring large numbers, optimizing complex systems, and something that never heard of is simulating molecules of drug discovery. So, yeah, it's pretty cool, pretty amazing. Of course, with all these powers, there are some really big questions. For example, quantum computers could potentially break the encryption that keeps our online information safe? This is because they are so quick to solve complex mathematical problems. Even AES algorithm, that is the most complex algorithm and has never been broken. But with quantum computers, I think our online safety is at risk. Uh, Never to say that we were never actually that safe regarding the privacy when we are living in a world where big tech companies can easily peek into our information. But then still, now the information, personal information and privacy is even at more stake. uh, and but it's also pushing researchers to develop new kinds of encryptions that could withstand the quantum attacks. Hopefully, they get to this point where encryption is even more safe than the minds of the hackers. But let's hope it happens. So, what's the bottom line over here? Quantum computing is still in its early stages, but it holds incredible promise. It's going to change how we approach problems from scientific research to cyber security. But like any other powerful tool, it comes with challenges and responsibilities. We are just beginning to unlock its potential. And the journey ahead is going to be fascinating for sure. So, with this note, I hope that you all got a better understanding of quantum computing and why it's such an exciting field. So I think I'll be ending the video right now, and I'd love to hear what your thoughts are on quantum computing. What new thing have you heard in the field of quantum computing, and what is fascinating you guys? In the comments, let me know your thoughts, and let's meet in another video. Until then, stay curious and remember the future is quantum, hopefully. And yes, it is going to be. Bye.